on the project now. Oh, this is fine.
No, they weren't.
The kernel, we might be doing some LangChain depending on how much time we have. But we're going to go over basically like the step beyond. So when you go to actually building an application, what are the kinds of things you can focus on? So the first thing we're going to look at is essentially how did we we're going to look at basically how did we get here to RAG. The first thing is the kind of science of information retrieval has been around for a while, I think since like the 60s or 70s. And there's kind of two very famous algorithms from the 80s, I believe. It's TF-IDF and BM25. These are essentially keyword search algorithms, very well known. What I'd say is, if you can get away with keyword search, do it. It's very performant, it's very cheap. So if you just need a keyword search, these are your algorithms. Kind of many decades after that came along basically neural network methods. So we had BERT and Sentence BERT from Google, and these were kind of pre-LLMs. They were kind of focusing on the encoding part of language models more so than the decoding part. But they were very useful, and they allowed us to essentially embed sentences and paragraphs and documents into embeddings, which was very useful for us. Then came dense vector retrieval, and this allowed us to have a lot more context for our embeddings and be able to kind of embed whole chunks and have kind of being able to compare that. And then came retrieval augmented generation, whereby we thought, this is nice. This is a good like indexing method. Let's use that alongside our kind of generation methods as well. So we've kind of covered this in the past. These are the kind of the other things we've done the last few weeks. But the things that I wanted to look at was, okay, now we have kind of RAG, we have like things like chunking, but chunking is not really that simple, right? If you just kind of naively chunk your document, you might end up with chunks that are too small, which means that basically each chunk doesn't have enough context for proper retrieval. And you could have basically fragmented information. So you could get 5 chunks, and there's a bit of information there, a bit of information, a bit of information there, and there's things in the middle that are missed. And so your model doesn't have the full context. End of the day, all we're doing is like text snipping together. So if it's too small, you could end up with that sort of problem.
These chairs, and then you can pass your chairs to the other side. You can look, because I want 2, 3 chairs on that side. You just move this here, and then more chairs come. Just move to the other side. You can. Please, one more chair, please, on the main side, and then you can.
With us on the stream, we're having some logistics difficulties.
I think you guys can sit here. I'll continue, please.
Okay, so that's the problems if our chunks are too small. If they're too big, what will happen is we are bringing too much context into our model, and it's not necessarily relevant context. So it could basically decrease the accuracy of our retrieval, because we could be bringing in stuff that's just not related to the user query at all, and it could confuse the model and point it towards the wrong direction. Not to mention as well that it's quite expensive. If we're bringing in massive chunks and we're doing, where K, which is the number of like chunks that we're bringing in, is like 10, then these are 10 massive chunks, and we could be really using up our tokens very, very quickly. There is a science behind this. It's not just kind of through feeling. So there are retrieval metrics basically based on measuring how your RAG system is doing. In the RAG, they're focusing mainly on retrieval because that's most of the stuff that we can control as developers. So the metrics that we care about are recall, which is basically the percentage of relevant documents in the top retrieved results. Precision, which is the proportion of the documents that you get that are actually relevant. And the mean reciprocal rank, which is just 1 over the rank of the first relevant result. You could target 0.75 for production systems, right? There are metrics that we track as well. So there's BLUE4 scores, which measures the n-gram overlap with reference responses. N-gram is essentially an alphabet that you compare, and then you use that to basically generate some knowledge. Or Rouge, I've never known how to pronounce that. Rouge L, let's say, is calculating the longest common subsequence between the generated and reference text, right? So let's say now you've got some metrics and you've come up with this really interesting retrieval technique. You need to compare it against stuff. So I would recommend comparing it against how we'd do against BM25, against dense retrieval, like kind of naive dense retrieval, and maybe covert. We'll get to covert in a bit, but it's another technique that we could use. Look at how your technique basically compares in terms of latency, in terms of throughput, and in terms of the resource utilization across the different retrieval methods. Also test across different domains. So different domains have different retrieval requirements. A law firm will probably have to require a lot of information and then find a needle in a haystack. Whereas kind of in the medical field, you could be looking at bringing lots of different documents together and then compare it. Right. So different domains require different approaches as well. Again, it's really important that you consider cost. These things can get really expensive, and if you're bringing in huge documents into your context, your platforms team will tell you your infra costs are going to go through the roof. Okay, now this kind of assumes that we're only doing kind of character level chunking, where we're saying every 250 characters. Give me a chunk. This is quite a naive way of doing it. Documents are not often just split up by 250 characters. They're split up by sentences, by paragraphs, by sections. So you can define basically logical boundaries in your document that you can split up your document in and use those as chunks rather than specific text sections. Yeah, and that basically means that when we pull in chunks into our context, we're not pulling in like half of a paragraph and sending it to the model. The model will see, the second half of a paragraph and it will think, I don't understand what's going on. Right? Where's the actual context? Whereas if you do proper semantic chunking, again, depending on your domain, it can be much better. However, semantic chunking needs upfront cost in terms of either human labor cost, in terms of you going in and working out what each part is, or if you're automating it and using LLMs for semantic chunking, it will cost you tokens as well upfront. But this is a one-time fee, whereas kind of obviously every time you use a...
So you mean it's a manually process?
It could be, or you can do it automatically, right? It's up to you, right? There's kind of, when you do also kind of sliding window chunking, so when you do kind of character chunking, you also have basically a sliding window. So to make sure that you don't have the example where you only have two chunks, one is like the first half of a paragraph, one is the second half of a paragraph, and they make no sense, right? What you can do is slide them. So you have like essentially the first half and then the first like middle quarter and overlap, exactly. And then also have that as well. So you have kind of essentially the overlaps as well to make sure that if it is retrieving, it's retrieving the right sections. Okay. No. Okay. So there are kind of new techniques that are always coming out with RAG. One of the ones that I really like is from Anthropic. They released something called contextual retrieval, which basically all it is rather than just having naive chunks, which you don't know which chunk is related to another, you do an offline processing step using an LLM to basically say, okay, this chunk, which chunks is it related to as well, right? And you add essentially a header to each chunk, which is the LLM generated summary of what it thinks that this chunk is related to in the wider document. They have found that this increases performance a lot. And what's nice as well is that Anthropic did it first with Claude. They did something called KV caching, which meant that if you make an LLM call and you make it over and over and over again, there's some optimization within the model itself that you're not making the same call. So they have some cost savings and they pass that to you. This is not just Claude now. OpenAI does the same thing. So Claude, you had to kind of explicitly say, I want to activate this. But OpenAI and Azure OpenAI, they do it by default now. So if you're making the same call over and over again, like with RAG, a lot of this stuff is cached and you'll end up with cheaper costs. So in terms of performance improvements for a method like contextual RAG, now contextual RAG is not the only kind of fancy retrieval method, but it is a good one. And this is kind of the stuff we care about, is that there was a 67% retrieval failure reduction for their metrics. They looked at the top 20 chunks for this. And they found that basically doing this improved performance a lot, but it came with an upfront cost. So you are not just naively chunking and working out the embeddings. Now you are going through every single chunk and sending it to an LLM and analyzing it to improve that performance. So it's a trade-off. Now, you don't have to go with one form of retrieval, right? So you could do something where you weigh different methods. So you use two different methods and you weigh the kind of outputs of the methods together. Like, for example, you could do lexical search through BM25, which is the algorithm we talked about earlier for keyword matching, and you do semantic search. So let's say for your example, you do actually care about keywords a lot, but you don't want to lose that semantic understanding. You can do both, right? And rank, for example, the lexical search as 80% and the semantic search at 20%, right? Or there's another kind of interesting approach. Well, first I'll go through this. Yeah, so you could basically, the user searches budget report Q3. At the same time, we'll do a keyword-based search and we'll do a semantic search. And we'll basically combine these two together depending on our domain and what makes sense to us, right? And another thing we can do with this is we can do something called like smart reordering, or sometimes we can hear it as called re-ranking. There's like re-rank algorithms you might hear in the literature. Cohere is famous for doing this sort of thing, if anyone's heard of them. It basically is the approach of using two different steps for retrieval. So we might use a really cheap retrieval step like BM25 because we have, I don't know, 10 billion documents. And we want to very quickly search across them. But we select the top 1,000 documents based on that. And after that, we apply semantic refinement. So let's say we use the covert algorithm to do that. We haven't covered covert yet. I'll get to that. But you can use basically any sort of more expensive refinement step. So rather than running your expensive refinement step on a 10 billion documents, you're doing it only on the top 1,000 that your initial search found. All right. Moving on to covert. This is a guy called Omar Khattab. He is a graduate here at CMU in Qatar. And he came up with this algorithm. Now, it's very, very famous, and I'll kind of go over why. He's now in MIT. Yeah. Really, really smart guy. But essentially, he came up with the idea of late interaction retrieval, which he called covert. And essentially, it's an approach of rather than like generating one embedding for each chunk, instead, we basically chunk up the chunks as well, right? And we generate more and more embeddings so that we almost focus at the token level for these embeddings. And we try and work out at the token level, how does it make sense alongside each one? So usually there's a single like 768 dimension vector to represent the document. But in covert, we essentially generate much, much more embeddings, much, much more embeddings. All right. And this is kind of expensive, right? But it led to considerable amount of performance benefit because it started, so rather than one embedding trying to represent a whole chunk, we are focusing on minute details and letting the model basically focus on specific things. So there's some applications, and I'll go over some of these in a bit, that need that sort of minute performance. And they really, really, really like do well with covert embeddings. So again, one of our own in Doha is Omar Khattab, and he came up with this among other stuff. He's actually like very well known in his field, and this is really impressive stuff. So, continuing with the covert stuff, let's say you have a whole bunch of documents that are not text. Let's say you have scanned 1 million books, right? And you want to do retrieval not on the text, but on the actual pages themselves, right? So let's say we have one particular figure or a graph or a result or an equation or a picture, basically anything in that page, but it's not text, right? We would have to do multimodal RAG in that case. And this is where covert comes in. right? Because there was some research done that was using cobert and a model called PaliGemma, which is a lightweight vision model, to generate embeddings, not for like text chunks, but for picture chunks. So they'd take a page and they'd cut it up into like 2048 sections and then generate embeddings for each one. And they found it works really well. And this goes back to what I was saying about cobert. With images, what they've found, if they naively turn it into embeddings, the performance is not great because the model doesn't know what to focus on, right? But using a technique like cobert to basically break it up into lots and lots of little pieces, it was enough attention for the model to learn like how to actually do OCR, how to look at a graph. The results are really insane. Like it even learned kind of, how to look at the x-axis and the y-axis at the same time when I'm thinking about a particular result, right? So there's some interesting stuff there. This is called ColPali. Again, it's kind of visual content indexing. So rather than at the kind of chunk level, we index at the page level and are able to say, okay, find me the figure in this book that says this, right? Really cool stuff. Real world example of ColPali, searching scanned contracts or research papers. It retrieves the relevant pages by understanding individuals, and it goes beyond plain text, like heading charts, tables, things like that. And this is really important because when you do naive indexing, you lose the layout of your document. So your kind of header could end up below your footer and all sorts of things. So this maintains that context, which is really useful for us and leads to good results. Okay, so that was kind of a cool technique, but where we are heading in the future is more towards something called adaptive retrieval strategies. So kind of a lot of the stuff we focused on was on the R part of RAG. This is more so on the augmenting, the actual kind of smart reasoning side of it. So rather than just thinking like, here's the query, find relevant documents, whether we need to or not, right? It's more like, here's the query, do you need to retrieve? How much do you need to retrieve, right? Do you need to, okay, now you've retrieved it, do you need to retrieve things further, right? So it's a much smarter way of doing RAG, but it's also more compute heavy, right? Because we have to generate essentially thinking tokens as well as just naively doing the retrieval. There's a really good paper called Adaptive RAG. I've linked in the presentation. I'll share all of this stuff that goes over all of these things. The reason why this stuff is useful is because we're adding essentially more compute to these things. So we are increasing the efficiency. So we're not just retrieving 5 documents that we don't need to for every query. And where we do retrieve it, we can, like, for example, transform the user query so that it's actually, the user might say, how do I sign up for Netflix, right? But what they actually want might be completely different to what they're actually querying. So the LLM tries to reason to understand, like, what is the user actually trying to do? What is the data that we should retrieve for them? And they can break it down as well. So let's say the user asks for actually multiple stuff in their query. In regular RAG, you might say, like, bring in 5 chunks, but they're actually asking for things that, require 50 chunks to be brought in. In regular RAG, this would fall apart, right? We would not bring in enough context and the query would not really go through. In this, you can get the model to essentially generate sub-queries given a user query. So the user said this, okay, now I need to retrieve this and this and this and this and this. There's a much smarter way of thinking about this stuff. The real world kind of applications for this are endless. I think now the hype is going insane for this sort of stuff. So OpenAI just released their research agent, which essentially is doing this alongside function calling to basically browse the web and be able to just say, pull in information. Okay, what else do I need to pull in? What is the user actually asking for? Let's break that down. Okay, this information has come in. Okay, that's changed things. I'm going to look over there now. Right. So that's the agentic retrieval now that's become mainstream. If you have $200 a month on ChatGPT Pro. Yeah, so that's where we're heading, basically, is that sort of agentic future. It's going to be interesting. I think it's going to be very compute heavy. If you're Microsoft, you'll do very well on this. And it will lead to, I think, much better user flows. But we need to work out how to do it efficiently. All right. Another thing is we are kind of approaching not just agentic retrieval, but also multi-agent retrieval now as well. So rather than having kind of one agent who is an expert research agent who is able to pull all this information, what if we also have like an agent who is also an expert at working with protein folding and has access to all of this software as well? And then you have multiple agents. How are you gonna orchestrate them? Then you have an orchestrator agent, and you're kind of reaching interesting system architecture design for these sort of agents that we as kind of software engineers haven't really worked with these sorts of black boxes like this. But yeah, that's about it. I've got some examples here of kind of what it does. So when a user query comes in, we analyze the query and generate a preliminary response using base knowledge to form targeted search criteria. This is to say that when we're doing search on embeddings, we're doing the search not on the user query. We're trying to find stuff that looks like the user query. But what the user asking for is not necessarily exactly the same as what's in our database. So what instead we do a middle step, where we generate some example data that we think that's what the user is looking for, and we search for that in our database. All right, and this improves kind of our performance. We can do some document retrieval as well. So we transform the kind of generated content into semantic queries, and then we get more and more documents. This is what I was saying about subqueries. And answer refinement as well. So let's say we do all that querying and we get an answer. We can get the model to reflect on its own answer and think, hang on, I've done all of this. Does this actually make sense? And try and get it to think about that again and generate a new answer based on all of this.
Here, for example, can you just back up the slides, please? Yeah.
Yep.
In document retrieval, you're saying, right? How much you trust on that way? Means like your accuracy point of view,
Yeah.
Like you have 10 billion or maybe something like this. When we past 10 years of data, documents, for example, putting on PDFs structure, right?
That's a pretty good question.
Means exactly he get the 100% because it depends, right?
Yeah, that's a really good question. And you're kind of hitting on the active research now. It's kind of the $1 trillion question.
Yeah, I mean, sometimes manual, till now, people are processing manually, so we don't trust on that way.
It's basically, how can we trust this sort of output? We're giving a lot of power to these models. It's a really good question. And it's essentially, this is if we solve this, I think we as knowledge workers are finished.
No, I cannot go that way.
But joking aside, it's a really good question, and it's actively researched. And I'd say the best way to know this is to measure it. Right. So we went through some of the benchmarks earlier on. Right. There's now kind of agentic benchmarks as well. that are coming out. So you come up with this incredible kind of system that you're building out, this incredible researcher, and you test it out on this massive benchmark, consisting of essentially question and answer, right? And does it produce the right answer that you're expecting? Does it veer off in other directions? You have to measure it.
Okay.
It's getting
still cannot trust on that way.
Sorry?
You still cannot get trust on that way. That is accuracy of this 100%, right?
How much do you trust?
I mean, like
anyone?
manual process, we trust. Like if somebody said, okay, our team sitting there, they for 10, I asked for the budgeting point of view. I need the data for the last 10 years.
Yeah.
They did their R&D and they come up, okay, this is the report. They have the league of team, right? Like
Yes.
10 people or 15 people. You cannot trust each one.
Yes.
Right? So they are a group of the people that we trust, okay?
Yes.
And then the same thing, what you means like you believe that, okay, the Azure, this module you run, and then you have to run open source module as well, the 3-4 module. So then see who's accurate on.
Yeah, but I agree, but you have to come into it from a scientific from a scientific way. It's one thing to just say from a human perspective, how much do I trust it, right? But you have to measure it, right? And that's where.
So which way and what is mechanism to measure it actually?
There's benchmarks, right? Okay. So there's a lot of benchmarks now. Basically, the industry is moving at a ridiculous speed on this stuff, and there's already benchmarks to do that. So, when we're talking about researchers, for example, there's benchmarks now that test how good of a researcher this algorithm is, right? So, it has a query, for example. It's a very complex query, and it wants the output in a very specific way, and it has the expected output, right? So you test it out. This might be like 100,000 examples, and you say, okay, well, it's 95% right on this benchmark, right? Is that good enough for me? Right? And you have to then compare it as, I think we as software engineers, we are very black and white, right? If something is wrong, it's completely wrong for us. But these things are not working on that level, right? If you're working on like a deep researcher like this, you mentioned kind of things like budgeting and things like that.
Yeah.
Right? They're done by people because we want them to be accountable. Right? And we also can track how much people make mistakes. And if they do mistakes, we can go back and we have people higher up and all of this. That's the kind of mentality we're going to have with these things as well.
Okay, so think like this way. You cannot be not trust on that way, right?
Exactly.
Mistake can happen again.
Yeah. It's, I think it's right.
For example, my concern, I mean, if suppose any organization, we approach on that way, okay, this is the module for you to solve this issue, right? They said, okay, I will take it for that way. Tomorrow they run again and they say, okay, it's not working for me. I missed some load. So this, all the things you have to be put on the table on the first page, right?
You have to measure it.
Yeah, exactly.
Yeah. And it's active research as well. So we're talking about this stuff. This is stuff that's literally been done in like the last year.
It will take time for.
At the research level, not as like this is a product. At the research level, it's been done in the last year. We are kind of all here ahead of the curve, but it will become mainstream because
It'll take time, I think, yeah.
The impact of this is ridiculous. But yeah, keep an eye out on it, and we'll get that 99.9.
Yeah.
Okay. Yeah, closing thoughts. I don't really need to read all of this out, but do you guys have any questions before I move on to other stuff?
So basically, in this actually retrieval model, so how the checkpoints are working in the backend.
I'm not sure.
Checkpoints.
What do you mean?
Because every time if you are going and searching, means it needs to index the millions of the document in the backend, right?
So you only index your documents once.
Exactly, right?
Right.
So without checkpoint, it needs more computing power. It has to store somewhere the last search index, basically. So how the checkpoints are working in the backend.
So you mean if they're updated?
Yes. Because DPR but everything basically, they are neural relative models basically.
Mhm.
The back end, so how the checkpoints are working, we just want to
It's the
understand.
same way. It's the same way that you would do it with any sort of database, right? So, like,
So that's the difference between the traditional one and the modern one. Because when you hit select start from means it will start from the scratch to,
yeah.
it will take more computing power, right? So how it will differ here?
Okay, I understand your point. So you're talking about basically like new data coming in and how
So
you,
for example, I'm processing the data, some point of time, network is got broken. Again, it has to start from the where it actually stopped.
yes,
So instead of starting from the scratch.
yeah.
So which means that in the backend somewhere the checkpoints are storing.
Mhm.
So how the checkpoints are working here?
It's the same way that you would do it for a non-LLM system, right? It's all data freshness, basically. So how much do you want to weigh in, basically, how recent that data is, right? So you've got a whole bunch of data, and some of it is quite old, some of it is not relevant to what you're doing.
Basically in the Gen AI model, basically there is a pre-trained models are available, right? So
Yes.
what kind of,
So you mean the data in the actual parameters or the data in the RAG database?
basically in the backend, actually there is a pre-trained models are available.
Yes.
Okay, so I think that in the backend, the checkpoints already, the pre-trained models are available in the backend.
Okay.
How it is relating here?
Okay. So the pre-trained models are kind of out of date the day they come out, right? So right from the beginning, they have then missing data. You can't ask it what happened today, right? But that's kind of where the RAG stuff that we've been talking about comes in, right? So rather than having kind of the pre-trained weights, we're bringing into our context new, fresh information that relates to your query, right?
Because in the Facebook, basically they are using Facebook AI social search.
Mhm.
Okay, that is the pre-trained embedded coding which they are using in the backend for the checkpoints. Okay, so for example, unfortunately you closed your Facebook.
Yeah.
When you're opening next time, it will start from where you exactly stopped actually.
But Facebook AI is not constant. It's not like being trained every day, right? They trained it once and are using basically retrieval to bring in fresh data into the context, not into the parameters. So you raise an interesting point. Before RAG, before kind of the guys at Facebook created what is modern RAG, Google came up with a similar idea of essentially the user has a whole bunch of data and we just basically fine tune the model every single time we want to do any sort of retrieval, right? So when the user types a query, at the same time, we fine tune the model and we give them a result like 2 hours later, right? That's one thing you could do. Obviously, that doesn't really work very well. Fine tuning is difficult and expensive and requires a lot of data. So that's kind of why RAG is really good, is because you're not having to retrain the parameters. The model is essentially smart enough to do what's called one-shot learning. So when you give it an example that it's not seen before, and then you ask questions about the stuff that it's not seen after, it will be able to answer questions, right? There are models before this, when you try to do this, it doesn't work. It only could use information from its parameters. Any other questions?
Hello. Yeah, probably not relevant to the session, just out of curiosity, just came to my mind. Have you maybe looked at DeepSeek's RAG implementation or what sort of?
Yeah.
How is the technology on their end?
Yeah. So DeepSeek is really interesting. It's just come out now. The kind of research behind DeepSeek has been around for like 9 to 12 months. It started kind of around OpenAI. And it was basically looking at LLMs were really good at kind of producing outputs and kind of the next token, but they weren't really so good at like reasoning. And there's something called symbolic reasoning, which is like another branch of AI. But they were terrible at that. Right? So they would give them like logic puzzles that on the other AIs, you'd give them and they'd work out immediately. That LLMs are terrible at. So the researchers were looking at, can we get LLMs to do this? So they tried a lot of different ways. One of the ways that they did was by getting the model to think step by step and reason basically across it. And that was kind of the initial idea. But what they did was to just get it to generate tons of reasoning, just tons and tons of reasoning, and essentially train the model based on like millions of these examples of reasoning that most of them are rubbish. Like, like if I have an orange here, then an apple must be here. No, I could have an orange here and not have an apple there, right? They generated things like this. And they use something called reinforcement learning to basically work out from these like gibberish reasoning what actually makes sense, right? And from that, they produce basically reasoning models that are really good at generating these reasoning steps based on some input, right? Now, what they've found is that when they produce this reasoning context, so similar to how when we bring in like our own data, suddenly our like output is grounded in real data. If you bring in this reasoning, it's a bit like doing RAG, but it's like you're plugging in like reasoning, like thinking into the output, right? And they found out that in certain things where it's like a logic puzzle or you're trying to trick the LLM or things like this, the LLM performs a lot better, right? Like my favorite example of this is have you guys heard of the Monty Hall problem, where you have two train tracks? One has one person on the train tracks, one has 5 people on the train tracks, and you stand kind of at the junction, and you have the option to change. Does it go to the one who's killing 1 or going to the one killing 5? Now, kind of the ethical problem is if it's already going to kill 1, if it's already going to kill 5, and that one person knows that he's safe, would you switch and kill that person, or would you just let it like go through? So it's an ethical dilemma. You can think about it, whatever. But you can change this problem to be.
What is your answer on that?
Sorry?
What is your answer on that way?
I'll tell you after. But you can change the problem to be that the train is going towards 5 people, but the 5 people are already dead on the track, and there's 1 living person.
Oh, that's
on the other side.
Condition now here.
Right?
Yeah, this is condition.
If I ask you that, and it's going towards the 5 dead people already, would you switch to kill the living person?
Anyway, that's why you say that the condition is already given the condition, right? These are 5 people already dead. So.
But to you, that's obvious.
Yeah.
You ask GPT-4o this, it's going to change to kill the living person.
Oh, I don't think so. It's going to change.
It will. I've done it.
Really?
Right? Yeah. So that's an example of kind of reasoning in action. What the LLM is thinking there is, hang on, I've seen this problem before. It looks like this problem. Usually this problem has this output, without really thinking about what is this problem, what's actually going on, like thinking deeply. It's not doing that. It's just, it's like a lazy answer, right? So even though it's obvious to us, there's clearly something missing. And that missing stuff is the kind of reasoning that you asked about. So that's what is the improvement in that kind of side of performance.
I'll go ask the model about this problem.
Okay. Ask who?
I'll ask the model.
Okay.
I'll give the problem to the model. See.
Sure. And tell me if yeah. Tell me how that goes.
If you do this, you lose creativity.
That's a good question. You could do, and basically they've benchmarked these models. So things like O1 and O3 and all of these things that are now coming out, the reasoning models, and they are worse at creativity, right?
Or
O1 models.
models.
Even though they do really well in things like the obvious, like, puzzles and logic and things like this, when you tell them to write like a very nice story, and you kind of produce a very nice story with GPT-4o and one with O1, you'll find the one with O1 is terrible. Right? And the GPT-4o one, it reads like a real story. So there is nuance in it.
You know how DeepSeek fares in that?
It's similar to O1. O1 mini anyway.
So if you get more logic, you lose creativity.
Yes, well, depends on how you train it. So there's a limited number of parameters in the model, right? So if it's a certain model size and you fine tune it a certain way, like they have done with the reasoning reinforcement learning, then clearly something is being lost as well. So it might be losing knowledge, it might be losing creativity. It's not an infinite model. But we'll see. Maybe give it a year and we'll have everything. Any other questions?
I have a question.
Sure.
How adding knowledge graph to the RAG solution will enhance the retrieval accuracy? How do you compare knowledge graph and graph databases,
Okay.
considering the relationship between the documents? And how do you compare it to what you have mentioned?
It's a good question. It depends on how good your knowledge graph is, right?
Yeah, because
So, and it depends also what you're asking for a query. If you're kind of querying about like very specific things in a way that you would ask kind of traditional databases, yes, I think a knowledge graph would do a lot better, right? But if you're coming into it and it's like the user is, you know, a 12-year-old kid asking about his maths homework, right? And they ask it in a very convoluted way, and they might mention that, oh, my teacher said this, and then I think the knowledge graph would not do so well, and things like RAG would do better. It depends on the situation. And also, there is something called graph RAG, where essentially, rather than having kind of a linear set of index documents, you let the LLM essentially generate a graph of your knowledge. This is a Microsoft thing. So it generates essentially like a connected graph of your documents so that you know that, hey, this chunk of documents, they're all connected together. They're all related. So if I retrieve one and I need more context, it's probably going to be around here somewhere, right? And then you can link it to others and things like that. So it's interesting stuff. Any questions?
Question on maybe we were talking about it, but I didn't hear you. How does interpretability fares in this? Like, if you get a chunk from a certain area, can you track back where it came using the model?
Yeah, interpretability is a big problem in LLMs, a big problem, because these models are ridiculously big, right? And for any kind of model to be interpretable, you need to actually kind of break it down. Like, for example, interpretability for like vision models, you make as small of a model as possible, right? But we're finding with LLMs that if you make them smaller, they lose very quickly their abilities. So I'm not saying that they gain abilities or whatever. That's a different thing, but it's hard to do interpretability, basically.
Maybe you can track, if not track back to the chunk it's used for reasoning, or maybe any kind of information out of how it came to the answer.
Yeah, so you can do some stuff like that in terms of output, right? So you can tell it, you can kind of do some fine tuning on your model to make it better at the next token being a good reference for the things that it's mentioned, right? So if it talks about a whole bunch of stuff and you want to then add like a reference or a website, you can fine tune a model so that it's better at doing that. But in terms of actual interpretability, right, and looking at kind of the neural, like the actual neurons, and working out, hey, switching off this neuron makes it forget about this thing.
Yeah,
it's not. There's some stuff about it, but it's. I don't think we're anywhere there. I think we have a long way to go on that.
Did you use any of those technologies in your project?
Yes. I can't say. Yeah, we do use it. And in terms of how we kind of use it day to day, it's essentially plugging in agentic workflows into our existing applications, right? So we have an existing, let's say, trading platform, right? And the users use it in a certain way, and there's certain patterns, or they kind of have to ask it to do a lot of things all at once. Rather than doing that, it's really nice to just have a natural language text input. So I'd say plugging into your existing systems is kind of the first step. Once you do that for free, what you get is essentially an API for your agent to use your application in whatever way it says. So when you do come up with more complex workflows, you already have the ability to tell it to do this in your application, do that in your application. So that's how kind of we use it practically. But we're still very early on. And a lot of the stuff we talked about is still actively researched, but it's moving ridiculously quickly. Like I've never seen anything like this. Like I've been following this stuff for like 10 years, and the last 4 years, just too fast. And so much money is flowing in, and there's so many different labs doing stuff, and they're all competing. And you saw like DeepSeek come out of nowhere. All right. It's hard to kind of stay on top of this stuff, but focus on more what you're trying to do, right? And then look at, hey, is there a technique to do that? Rather than, what's the newest technique? How can I use that in my application, right? Definitely be product-led rather than technology-led.
Yeah, you mentioned about the enterprise document assistant, right? Like what would be the workflow? Because in terms of the document assistant, we might have internal forums and other like the support articles as well, right?
Yes.
How the input and like the pipeline is going to work?
Yeah. So this has become a classic application of systems now. Is any sort of large enterprise has a huge amount of internal documentation, and it's really hard to search across it, and it's really hard to understand it. So they've named basically any big company, and they've already done this now, is they've essentially chunked all of these documents, indexed them using embeddings, and given their employees a chat interface to.
Will the banking part itself, it will handle that kind of like the duplicates data? Because all the things, it will be the same, right? Like for support.
Yeah, it can. And having used some internal systems like that, they're definitely not perfect. And sometimes I just end up, I'm not using this. I'm going to have to search it myself. All right. So it's not easy to build those sorts of things. And I think some companies think they are. Okay. I actually came up with a little demo as well. So I put together this UI basically demonstrating like how kind of regular RAG works. So for like regular RAG, I can ask it something like computer vision, and it will do the query analysis, retrieve the relevant chunk, and generates a response here, right? So it found out I was talking about computer vision. It saw that this chunk is the relevant one, and I've given it. So this is kind of the semantic chunking I was talking about. So these are all kind of essentially paragraphs to do with this stuff, pulled from a knowledge base. I've given it tags as well, so you don't have to search on only one knowledge base. You can like search across multiple things at the same time. So it found this chunk because it has the computer vision text in there, and the chunk is also there as well. And it generated a response talking about computer vision based on the input that we gave it. All right, so this is kind of regular RAG. Adaptive RAG is a little bit different. So let's say rather than I just want to get documents about computer vision, I say to our system, what can I do to improve my learning about computer vision? Now, it needs to basically process now, okay, what has the user done before, right? What kind of documents can I link them to? What's a good way of teaching someone? All of these different things. So we're breaking this down into multiple parts. So if I process this, this is kind of an example of like adaptive RAG. So on the left-hand side is like a timeline of what we're doing here. So first of all, we're doing query classification. So we're saying, okay, we're analyzing the learning needs and the current knowledge level. right? So we're pulling in certain bits of information there. Next, we're doing the knowledge retrieval, and we're pulling in kind of context that's relevant for us here. So yeah, like the available learning paths and the identifying key concepts. Next is doing kind of chain of thought reasoning, because we think that we need that to actually kind of put stuff together. So this goes back to the DeepSeek stuff you talked about. So you can actually call DeepSeek as a reasoning API, right? So it's not even just to generate output, it's just to generate the reasoning, right? And then the final one could be a step like response generation, where we pulled in all this information. How do we actually display it to the user in a way that makes sense, right? So this is the output on the right-hand side. Before doing that, this is kind of a big part of the adaptive RAG process, is essentially strategizing about the user query, right? So can you guys see that okay? So it basically thought about, okay, given this query, what should we do, right? So first we're going to do some sort of skill level assessment. Then we're going to do a knowledge gap analysis. Then we're going to do a resource retrieval. Then we're going to generate the learning path. And then we're going to set some exercises based and base the difficulty based on our learning level. And then basically synthesize everything else. And it says basically that the query requires complex analysis of current skills, learning path, planning, and multi-step reasoning to provide personalized recommendations. Right? And the kind of output that you can expect, for example, is this is your personalized learning path. Right? So based on your interest in improving computer vision skills, I've analyzed your query and detected familiarity with basic concept. You seem to understand fundamental image processing and have exposure to blah, 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 blah. Recommended next steps. So this is maybe another step that we add as part of this. These are the resources, maybe it's pulled from our system, right? And these are the kind of exercises that it's also generated as part of this. Now, this is all kind of mocked out. This is exactly kind of the flow though. And if you want a really good example of this is the Microsoft Learn website. They have a really good example of agentic flow. So they'll ask you questions about what you already know and come up with a whole kind of workflow based on that and what your goals are and things like
I
this.
just know, as I know that support Microsoft.com doesn't use still the RAG system, and that they didn't still enhance their.
I'm not the one to ask on this.
So they are just giving the main use case as an enterprise knowledge base, which we are doing also, but still they are not doing the backend on their own knowledge base. So
I'm not saying anything. No, I mean, this is not for me to say. But they do have some really good agentic stuff,
Yeah.
Microsoft. And I think the learn.microsoft.com stuff I found really, really cool. I think it's not perfect, but it was a really nice implementation of this stuff. And Microsoft does some really interesting research. Like I was talking about GraphRag, that's a really cool Microsoft project. And they do now, one of the things they're doing is automated computer use. So getting the LLM to generate like mouse clicks and kind of move your mouse and type for you. And I can only imagine the amount of spam that will.
Yeah.
Okay.
Good, thanks so much.
Thank you.
So nice presentation.
How do you deal with like outdated docs in like an enterprise document retrieval thing? Your chunks have some weight and those weight needs to be overridden. Or how does that work?
Updated chunks?
Yeah, if let's say there's a new document that needs to override an old document. So those chunking process that you went through, kind of have to do that, redo that, and then.
Yeah. So with this stuff, it's the same way that you would deal with it in any other system, right? So if you have outdated data, you'll update it and get rid of it, or you'll mark it as don't use, or however you want to do it. At that level, it's not really LLM focused, it's retrieval focused, and it's like any other database, right?
Switching from to post.
Could you give some use cases in my day-to-day application development time where I can use this RAG model?
Okay, so what does your day-to-day include?
Just assume that I'm building on web application.
Okay.
That so how can I use?
Okay, I'll give you an example. So are you like a software engineer or what
No.
is your...
I'm cloud solution architect.
Okay. Okay, sure. So let's say you're a solution architect, and in that case, you have a lot of knowledge that you have to deal with. You have best practices that you have to generate. You have to generate things like diagrams, and you have to communicate with certain people and all of this stuff, right? This is an agentic flow in itself, right? So you can pull all of this stuff together, come up with a strategy, right? Connect it to certain tools. So you can connect it to, like, for example, an agent that is really good at generating diagrams, right? And that's going to be kind of one part of the flow. Then you're going to kind of create a strategy based on this, send it off to our diagram maker. The diagram maker comes back. You check, has it done the right thing? If it has, great. You add some like blurb to it. Okay, great. You call another agent. Okay, who should I talk to now about this? Okay, it basically comes up with a list of people to talk to that are relevant to all of this. That's the kind of flow that you could think about, right? Is like breaking down your problem.
How the RAG is part of this flow?
Well, the RAG, it's information retrieval, right? So in your case, you know, if
consider this case, any case,
yeah, but like I think it's good to focus on the like kind of real concrete examples. Like in that sort of case, is okay. The user has come in asking for this. What is the internal documentation, for example, that I need to consider? Right, that is RAG, right? But it can also be things like, okay, I don't have this information. It's too recent for my knowledge, right? If you go and search the internet, this can be considered RAG as well, right? You're retrieving data from the internet, and then you're augmenting your model, and you're generating some sort of output as well. It's anything where you're retrieving and you're adding to your context is RAG. Sorry, does that make sense?
Give some more concrete examples.
So just give me the existing solution which use the RAG.
Maybe I can take this.
Sure. Yeah.
All right. Hello, everyone. For those of you who don't know me, I'm Fatma. I'm part of Microsoft Data and AI CSA. So who here has heard of ColPali? Right. So ColPali is an example of RAG, right? So how is it? Let me just go ahead and share my screen if you allow me.
Sure. Yeah.
So I'm going to go ahead and show you. This is my ColPali experience. Right. So you could see it knows who I am as a user. It knows that I'm Fatma. I'm a data and AI CSA. It knows that I work with Fatah. It knows who's my manager. It has access to my calendar, all my M365 data that's there, and it has access to all the material that is internally available at Microsoft and so on. So the model that's at the back, it's what? GPT-4o. But how does it know how to answer a question? So, hey, I have a one-on-one coming with my manager next week. What do you think some of the topics I should discuss with them? So how does RAG come in play? So it takes in my user query. It retrieves all the relevant context. So it goes to my calendar. It goes to the database. It goes to SharePoint. It goes to some recent email exchanges I might have had. It understands all of that, my team's chat, things that it has access to, and then it gives me, once it has the context, right? So it retrieves it, it augments the context, and then it can answer my question, right? So this is most of the use cases of AI that you see out there, it's utilizing RAG. Copilot, even, I don't know if you guys have interacted with GitHub Copilot. If you haven't, it's a life changer. If you guys are coming to the Web Summit, make sure to visit our booth. We're going to have a lot of interesting demos about GitHub Copilot. So GitHub Copilot, for those of you who haven't used it, it's free, by the way, now. So you just go to your VS Code and then just click on the GitHub icon, and then it has the context of your code. So if you just got to tell it, so how can I change this part of the code to be like more secure, or what are some vulnerabilities that I haven't considered? So it retrieves my code as the context to answer the user question. So almost every use case you see out there, it utilizes RAG because it needs to get the context from somewhere in order to answer the user question. Right. Anything you want to add to that, or anyone else that has experience building
His
RAG?
question was, as a cloud architect, how are you gonna implement RAG on? This
What
was the
was your name
question,
again?
yeah.
Oh, you're Charlie. Did you get a chance to get some coffee? The machine was not working,
Wow, you got
right?
one.
We fixed it. Anyways, so I'm also a cloud solution architect, and let me tell you, these RAG solution is, and I think Fatah he's also a CSA. These things help us a lot. So examples like I give just now, I have a meeting coming up, prepping for that. I have a lot of times you have to do architecture reviews, right? So you could give your the copilot that we have, like, we have some copilots that know how to review architectures, because it has access to so many architectures out there, like best practices, conflict reference architecture, and so on. So you give it literally just an image of your architecture and say, hey, what are some things that I might have not considered here? Is it following the architecture framework? Are there any like vulnerabilities I haven't considered? How can I make this diagram more low level to consider the network connectivity between the different components and all these things? So all these things, RAG comes into play to allow you to actually interact with these generative AI models.
So the biggest thing is basically, so far RAG is basically it's a SaaS model. Okay, so
in this example, yes, this is in ColPali. So you can customize it. This is what Hassan has shown. So he used the AI. I'm not sure if you showcased them like any diagram or any architecture diagram.
No.
All right, but it's the same idea, right? So you have the AI model, and then you have the retrieval, and then he built an orchestrator to sort of take the user question and over several steps, as he showcased in that UI earlier. A very cool UI, by the way. That's what it's doing. So if you want to customize it, then you can go with that approach, and we work with a lot of customers doing that. And then Copilot or other, even ChatGPT, if you have maybe the Pro one, it's using Retrieval as well. Because if I go here to the web, it does RAG basically, because I ask it a question like, tell me, I don't know, what should I ask it?
How to get promotion.
Like, who is the CEO of Microsoft, right? Oh, by the way, who knows who's the CEO of Microsoft? Let's guess your Microsoft. Yes, Satya. He's actually going to be, he's actually in the region right now because we have the AI tour at Saudi happening. So as you can see here, it accessed the web. So as you can, it went to Wikipedia to fetch this information for me. So this part, this knowledge, it could have been embedded in the model itself. We talked about like the trained model, but because it wants to get the most recent one, it retrieves the knowledge from the web.
So that's the thing I'm asking. So
yes.
Is there any possibility we can build our own LLM model in my own ecosystem?
You could reuse.
Everything is talking to the internet. But I don't want to talk to these things to the internet. I just want to build my own LLM model in my own ecosystem.
Right. So we have. So you need to understand that these large language models, they require a lot of compute. Right. We're talking about gigabytes and gigabytes of memory. So you need. So that's the infrastructure that's needed. You could also. We have a lot of customers working on such use cases. You could deploy it in a virtual machine that has GPUs in a private network, and then run small language models that are now, if you guys have heard of maybe 5.4 recently came out. There's other small language models on the market as well. So you could deploy it in a VM, and you can use it. You can build your own, because it's just the API that you call at the end of the day. Right, whether that model runs in your own private virtual machine or it's like running somewhere else, it's just an API that you call.
Yes, the short answer of your question, if you have enough GPU in your environment, yes, you can build your own LLM with your own data and train it, and then you can use it.
That's where the local LLMs concept.
That's why the local LLMs. For example, I know one of our customer. What they are doing is they have a 10-year-old firewall box. Okay, so they clean up this data. They train a model on their own GPUs, Okay, and now they are monitoring their network attacks, and predict if this attack is a real attack or it's a false positive. That's what they did, for example, with their own LLM in their local environments. But they have the GPUs. Yes, you can. Or maybe if you heard about this latest announcement from NVIDIA, they built a new PC, small PC, right? 3 GPU. If you have the GPU, yes, you can do it. But
So in Azure, we have 10 series VMs, right? Can we?
Yes, you can. And we have a lot of customers doing that as well.
yes.
Yeah.
For example, let's say another use case for you. You have tons of ATM machines, right? And these ATM machines need checkups or service. If you can place some IoT devices in that ATM machines, which send you some heartbeat of these ATM machines, and if you can collect this data on your database and integrate it with the RAG, with your LLM, so you can check which ATM machines needs a service coming weeks, for example. It will analyze the heartbeats of these ATM machines, and it will give you some suggestions, for example, to just come in my mind, and think loudly. Or think about your internet banking application. You have the customer data, you know their profile, their credibility. So you can use AI, which customer that you can give a loan, or he's gonna ask for the loan with the last 10 transaction, looking for his last 10 transaction, and you can suggest him to give a loan by using some LLM at the background. Just thinking loudly. Think about this kind of business cases in for your organization.
Before I continue with some other announcements, Hassan, do you have any other things?
I'm all done.
Oh, thank you very much, Hassan.
Thank you.
Thank you.
Switch off the live session, so you'll start your own parts.
Sure.
Okay.
So just building, I have a couple of announcements here, but maybe since it was mentioned here, maybe it's good for those of you who maybe haven't heard